Let's talk about the definite integral and the signed area. We know the solution to a definite integral gives us the signed area in region, bounded by its graph. We discuss in two cases. Firstly, for the integral from a to b f of x dx, the solution of this definite integral is the sum of signed area bounded by f of x and x-axis on interval a to b. And we could use what we learned from the last video, area between two curves. We know the x-axis, that means the horizontal line y equals 0. We let the another function g of x equals 0. Therefore, this integral a to b f of x dx equals f of x minus 0, that means minus g of x. That's just the sum of the signed areas bounded by these two curves. The second case, for the integral from a to b, fx minus g of x dx. So by the first case we learned, we could just get a new function d of x equals f of x minus gx. Then the definite integral is the sum of the signed area bounded by this new function and x-axis. Or we could just extend the learning from the area between two curves. For the upper curve minus lower curve, we get the positive area. The lower curve minus upper curve, then we get a negative area. Let's do some deep learning. On the interval a to b, if this f of x is above g of x, that means f of x is greater than g of x, then the area is positive. So this integration, the solution is positive. If g is below, f is above gx, then the area is negative. Vice versa, if f below g, then this f minus g less than 0, definite integral is less than 0, then the area is negative. G backwards, g minus f, then the area is positive. Now let's illustrate what we just learned by Python. Same as our last video, we import matplotlib on PySympy. The first example, this f of x is a quadratic function, and let's evaluate the definite integral. The interval is -3 to 6, and the signed area are bounded by fx and x-axis. F of x, 2x squared minus 4x minus 15. Plot f of x, and we also plot the x-axis because we want to get the area bounded by f of x and x-axis. Then fill in the area by color. Now let's run the code. You see the solution is these three areas. The little one, the left one is positive because it's f of x above x-axis, and this middle area is negative because below this x-axis. And this one is positive, so positive area minus this area and add this area is our solution. We could manually calculate the definite integral, and we get the answer -27. We also could use Python to get the answer. The answer is exactly same, -27. Now let's move to the second example. We have two continuous functions, f of x, x squared, and another function is 4x minus x squared. The interval is 0 to 4. We are going to evaluate two definite integrals. First one is f minus x, and second one is g minus f. So define those two functions first. Then we plot those two functions in different colors. Plot those two curves in different colors. And we draw the x-axis. Fill in the area by color. Okay, we see the red one is g of x. The blue is f of x. Here we extend the interval from 0 to 4. So then you see these two curves as the intersection point. The left area and this is right side area. Now let's get to the absolute value for both area. So the little one, the left side one is, we get is 8/3. The right one is 40/3. And we could calculate the area by the definite integral. So first one, f minus g. So f minus g is blue minus this red. So for the left side area 1 should be negative because the blue f minus g, f is below that, so it's negative. The area also negative. This is f is above this g, so this area is positive. So we would see is negative area 1. Area 1 is negative, so we put this absolute value as a negative. So negative 8/3 plus positive 40/3, we get 32/3. And backward, g minus f for the first interval, g minus f, g above f. So this area we should choose positive, and g minus f, the second area, we need to choose negative. So is positive area 1, the left side, and the right side negative. So 8/3. So the 8/3 minus 40/3 is just opposite. This is positive 32/3. This is negative 32/3. Now we could prove by the Python code, define these two difference functions. D1 is f minus g, D2 is g minus f. Then we plot those two new functions, represent the difference of the two functions. Plot the x-axis and let's shade the area for d of x, d1, and the x-axis. Another is bounded by d2 of x and the x-axis. See, we get the answer matches what we just get manually. So 32/3, and another is negative. Then by the graph, you see there actually is symmetric along this x-axis. The light blue one is f minus g. So the light green one is f minus g. You see the under this x-axis, this area is much less than this one, above the x-axis one. That's why our answer is positive. For g minus f, you see this area, the blue color, is above x-axis is smaller than this one. So that's why our answer is negative. I hope this video is helpful.